When two waves of the same type meet and overlap, they superpose, producing a single wave. The principle of superposition of waves states that when two waves meet, the resultant displacement at that point is equal to the sum of the displacements of individual waves, as you can see on these diagrams. When two progressive waves continuously pass through each other, they superpose, and the effect is called interference. When two waves are in phase, the maximum positive displacements from each wave line up. This causes an increase in amplitude. This is known as constructive interference. When two waves are in antiphase, the maximum displacement from one wave lines up with the maximum negative displacement from the other wave, and the overall amplitude is decreased. This is known as destructive interference. If the two waves have the same amplitude, the resultant amplitude will be zero and cancelled out. Coherence occurs when the waves emitted from two light sources have the same phase difference. The waves must have the same frequency. Minima and maxima are created. They are plural terms for minimums and maximums. Minima are formed when two waves interfere destructively, and maxima when waves interfere constructively. They are created by waves travelling different distances from the source. This is known as the path difference. If a wave has travelled an even number of half wavelengths, so a whole number, maxima is formed. If a wave has travelled an odd number of half wavelengths, a minimum is formed. You can find this out for yourself. When two loudspeakers are connected to the same signal generator, they will emit coherent waves. The waves overlap, forming an interference pattern which is made up of maxima and minima. Move your ears and you may be able to hear sections when the sound is louder and others where it is quieter. Interference patterns can also be formed by using microwaves. If the waves travel through a double split, an interference pattern can be detected by a microwave detector connected to an oscilloscope. Moving the receiver in an arc detects the maxima and minima that are formed, and this can be marked on paper. Young's double slit experiment involved light being passed through a monochromatic filter, through a single slit, then through a double slit. The filter only lets certain frequencies of light through. The waves travel through one slit and are diffracted, so they reach the double slits in phase. The waves hit the screen and bright and dark fringes are seen. This experiment shows the wave nature of light. We can work out the wavelengths of the different colours of visible light. The equation is the wavelength is equal to AX over D. A is the separation between the slits, D is the distance from the slits to the screen, and X is the separation between the fringes on the screen. This equation only applies if the distance between the slits is a lot smaller than the distance from the slits to the screen. To avoid using a filter, a laser can be used as it is a monochromatic light source.